Okay, our next shape here is the kite. So we have Kira here, and the definition of a kite is a quadrilateral, so four-sided shape, with two pairs of consecutive congruent sides. So these sides here being congruent, these sides here being congruent. Now remember, one of the properties is that we have a set of congruent angles between the non-congruent sides. And that's because if you imagine there's like a line of symmetry here, we could essentially prove that these two triangles are congruent based on side, side, side. Therefore, those angles are the same. Okay. And then some of our other properties here, our diagonals are perpendicular, so they create right angles. Okay. And then essentially what we end up with is we end up with two sets of congruent triangles in this diagram, right triangles. So these two triangles here are congruent to each other, meaning all of their parts that correspond to each other would be congruent, and these two triangles here would also be congruent to each other, and all of their corresponding parts would also be equal, all the sides and all of the angles. So the blue triangles are the same, the pink triangle or orange triangles are the same. Okay, so I'm going to give a different angle measure here than what's on your practice test so that you can kind of watch me go through it and then you can try it on your own. Okay, so I'm just going to give a random angle measure for this one. Let's say this one is 20, let's do 23 degrees. Okay, and then let's give our other angle measure here. Let's say this is 55 degrees. So based on that, and you do actually need two angle measures in a kite in order to find the rest of the angle measures. And one of the angle measures has to be in one set of congruent triangles. So like you need an angle measure in one of the orange triangles pairs, and you need an angle measure in one of the blue triangle pairs. Otherwise, you can't use them to kind of help each other figure them out in the other ones. Okay, so first thing we do is we know that these are all 90 degrees at the center, 90, 90, 90. And we also know that there's congruent angles here, so these would be 23. So these angles are corresponding, they match up with each other, they would be equal. Okay, now we would need to use our triangle sum theorem, that in a triangle we have 180 degrees. We can subtract 90, and then we can subtract 23. So for that, we're going to get 67 degrees. And that's going to give us our missing angle measure here. And that would be the same here. So you're almost seeing this as a set of congruent triangles. So these two triangles here being congruent, and they're really not related to the angles in the other two triangles at all. They're essentially just connected to create the shape, the kite, but there's no real relationship between the angles here and here. And you can't use them to find the other ones. So now what we got to do is look at these two triangles as congruent. Okay, so that means there's a 55-degree angle here. And then what we can do is use triangle sum theorem again. We can do 180 minus the 90. These are all 90s, right? And we can subtract the 55, and that gives us 35 degrees. And so that's going to be 35, and that's going to be 35 here. So all those angles are congruent, or corresponding and congruent, rather. Okay. In our diagram here, we need to know first that a quadrilateral has 360 degrees. So any shape with four sides, it can be rectangle, rhombus, square. Quad has a sum of 360 degrees. So we can kind of use the quadrilateral sum theorem, just like we use the triangle sum theorem. So the first thing you're going to do here is we know that angle W and angle X, or Y rather, angle W and angle Y, those angles are congruent to each other. Okay, you almost imagine, remember if we drew this diagonal here, we would create two congruent triangles, and so the triangles on either side, angles on either side of it would be equal to each other. Those match up with each other. And then what we would do is we would say, okay, once we solve for X, so we're going to set these equal, you're going to get a value for X. You're going to plug that in here. And you're going to figure out what measure of angle Y is. You're going to figure out what measure of angle W is. Then what you can say is measure angle X plus measure angle Y plus measure of angle W plus the measure of angle Z equals 360. Okay. And then lastly, we have a problem involving the sides of a kite here. So I'm going to add my right angle symbols in the middle, but diagonals are perpendicular. We know the length of EG, that's this entire side here, is 29. We know the length of HG, this piece here, is 8. So I've got this whole piece as 29. This part here is 8. We're going to need to use some segment subtraction, essentially. So we have an entire piece of a segment as 29. Here's G, here's H, and here's E. So this part's 8. And so we're looking for this missing part. Or I'm guessing we're going to be needing that part. We also know that DF, that is 20. And these parts here are equal to each other because these two triangles are congruent. So their parts are going to be congruent, right? So this length here is 10. And what we're looking for is an angle measure, okay? So in order to solve for that angle measure, DEH, that's this one here, we are going to need another piece, or this piece in this triangle, because we're going to use like an inverse sine, cosine, or tangent ratio. Okay, so first thing is finding this missing piece using segment subtraction would be, okay, 29 minus 8, that should give us 21. So I'm going to put a 21 here. Now we have a right triangle that we can essentially focus on. So that right triangle would be here. We have a side length 10. We have a side length 21. We have a side length that we're solving for, DEH. So you're going to use an inverse sine, cosine, or tangent ratio to solve for that. I'll put my angle measure back there. So this is the angle we're solving for. I'll call it theta for now. This is 10, this is 21. It's a right angle, right triangle. So you're going to use inverse of sine, inverse of cosine, or inverse of tangent based on what type of sides these are. So identify them as opposite legs, adjacent legs, or hypotenuse.